All right, this is the next lesson in geometry. We're still on the unit called quadrilaterals, and today we're going to focus on trapezoids. Okay, so a trapezoid is the first definition. A trapezoid is a quadrilateral with exactly one pair of parallel sides. Okay, exactly one pair of parallel sides, not two pairs of parallel sides, because that would be a parallelogram. These are trapezoids today. Okay. The parallel sides are called the bases. The parallel sides are called bases. The base angles are formed by the base and one of its legs. And the non-parallel sides are called legs. Look at a diagram of these in a minute. Okay. If the legs are congruent, then the trapezoid is called an isosceles trapezoid. That's if the legs are congruent. Okay, so here we go. This is a trapezoid here because we have one pair of parallel sides. So AB, you can see, is parallel to CD, so that's a trapezoid. And these are the bases. AB is a base, and DC is a base because those are the sides of the parallel. And then the other two sides are called legs. So AD is a leg, and then BC is also a leg. And then we have two pairs of base angles. So angle A and angle B, for example, these are called base angles. And then you have another pair of base angles, angle C and angle D. Okay. Now we have a few special theorems that talk about trapezoids, isosceles trapezoids, I mean, okay? Both pairs of base angles in an isosceles trapezoid are congruent, okay? So for example, if you know this is an isosceles trapezoid, then you can say that angle A is congruent to angle B. And then you can say that angle D, this entire angle, is congruent to angle C, this entire angle, okay? And the other thing that's true about isosceles trapezoids is the diagonals are congruent, okay? Again, this is only for isosceles trapezoids. These two theorems apply, okay? So in example one, we're going to prove one of those theorems I just gave you. We're going to prove that the diagonals of a trapezoid are in fact congruent for isosceles trapezoids, okay? So again, given an isosceles trapezoid, let's prove the diagonals are in fact congruent, okay? So we're given that MNOP is an isosceles trapezoid. Okay, so that's given to us. That'll be my first statement. We want to prove that MO, that diagonal, is congruent to NP, the other diagonal. Okay, so since MNOP is an isosceles trapezoid, then it means that the legs are congruent. So it means that MP has to be congruent to NO because it's isosceles. So that'll be my second statement. I'm going to say that segment MP is congruent to segment NO. Okay, 6 steps, I believe this is. That's the definition of an isosceles trapezoid. Okay. Okay. Now remember, I can use anything I want in this proof except what I'm trying to prove. So here's what I'm going to say next. I'm going to say that angle MPO is congruent to angle NOP, because the base angles in an isosceles trapezoid are congruent. I'm using 3 letters to avoid confusion. The base angles in an isosceles trapezoid are congruent. There's no theorem name for that. Next, I'm going to use the reflexive property. I'm going to say that I'll say PO is congruent to PO, reflexive property. And now we have 2 congruent triangles above. Because, and again, you might want to draw 2 separate triangles, but we have triangle MPO congruent to triangle, so MPO is congruent to NOP. Side, angle, side. Side, angle, side. So if that was too confusing, you might want to draw 2 separate triangles to help you see that better. Okay, draw 2 separate triangles to help you see it better. But now, since I have the 2 triangles congruent, I can say that segment MO, first and third, is congruent to segment NP, first and third. CP, CTC. Corresponding parts of congruent triangles are congruent. Okay. Last thing on the second page, the segment that joins the midpoints of the legs of a trapezoid is called the median. You may also hear that referred to as a mid-segment sometimes. I'm going to use the term median though, okay? So this is a median, okay? It joins the midpoint of the 2 legs of the trapezoid, okay? See, this is the midpoint of the side because this is congruent to that. And that's the midpoint of this side because this is congruent to that. So it's called a median. We did medians and triangles already. Now we're doing medians and trapezoids. There's one theorem you have to know about that. The median of a trapezoid, so EF is a median, okay, is parallel to the bases. So EF is parallel to AB and DC. And its measure is 1/2 the sum of the measures of the bases. So EF equals 1/2 of AB plus DC. Okay. Because here we go. Example 2. QRST is an isosceles trapezoid with median XY. Find TS if QR equals 22 and XY equals 15. Okay. So I guess I'll label that. QR is 22. XY is 15. Okay. So we're going to use this theorem above. For the median, which is in this case XY, equals 1/2 of TS plus QR. So 15 equals 1/2 of TS plus 22. What I would do now is I would just multiply each side by 2 to get 30 equals TS plus 22. Just multiply each side by 2. And then subtract 22 and you get TS equals 8. Find the measure of angle 1, the measure of angle 2, the measure of angle 3, and the measure of angle 4. If the measure of angle 1 equals 4a minus 10, and the measure of angle 3 equals 3a plus 32.5. Okay. Okay, so first thing, we're given the measure of angle 1, the measure of angle 3. These are same side interior angles because these three sides are parallel. QR is parallel to XY, which is parallel to TS. These are all parallel. So angle 1, angle 3, these are same side interior angles, so they're supplementary. So I'm going to say that the measure of angle 1 plus the measure of angle 3 equals 180, and let's solve it. Let's solve for A from there. So 4a minus 10 plus 3a plus 32.5 equals 180. Combined like terms, 7a plus 22.5 equals 180. Subtract 22.5, and you get 7a equals 157.5. Divide by 7. A equals 22.5. That's okay that it's a decimal. A lot of times people might think that's wrong, but that's right. Now let's find the measure of angle 1. The measure of angle 1 equals 4a minus 10. So that's 4 times 22.5 minus 10. So it's 90 minus 10. The measure of angle 1 equals 80. Now, if you look above, angle 1 and angle 2, these are base angles. And earlier in the lesson, we learned that they are congruent for isosceles trapezoids. So if the measure of angle 1 equals 80, then the measure of angle 2 also equals 80. So let me do that next. And now let's do the measure of angle 3 over here. The measure of angle 3 equals 3a plus 32.5. We should know it's 100 because 180 have to add to 180. But let's just do it out anyway just to be sure. The measure of angle 3 equals 3 times a, which we already established is 22.5 plus 32.5. 3 times 22.5 is 67.5. Plus 32.5 does actually equal 100, just like we suspected. So the measure of angle 3 equals 100 degrees. Good. And again, looking above, 3 and 4, these are base angles, and they are congruent in an isosceles trapezoid. So if the measure of angle 3 equals 100, then the measure of angle 4 also equals 100. Okay. Example 3, find the value of x so that trapezoid PQRS is an isosceles trapezoid. Hold on 1 second. I have to fix one thing. There's one typo. Hold on. Okay, here we go. Find the value of x so that trapezoid PQRS is isosceles. Well, if it's isosceles, then it means that the base angles are congruent. So it means that angle Q has to be congruent to angle S. So it means that the measures must be equal. So the measure of angle Q must equal the measure of angle S. So it means that 2x squared plus 19 must equal 4x squared minus 13. Subtract 2x squared on each side. Add 13 to get 32. Divide by 2. 16 equals x squared. You put the x on the left. I like to do it like that. And remember back to algebra 1. If you want to solve this, what you can do is you can take the square root of each side, so it leaves you with just x, and you do positive and negative square root of 16. That's going to give you x equals positive and negative 4. Now let's see if both answers actually work, because x can be negative. If you do negative 4 squared, you get 16 times 2 is 32, plus 19 is 51. If you do negative 4 squared, you get 16. 16 times 4 is 64. Minus 13 is also 51. Okay, so they both work. Positive and negative 4 both work. And so that means this is my answer. X equals positive and negative 4. You can circle that, or you can write x equals 4, circle that, and write x equals negative 4 and circle that. But these both work. Okay, and that is the end of that lesson. That lesson was called trapezoids.